Right, so guys, 2019 section B, our core graphics. We have our axonometric question here, okay? So, the image on the right shows a packet of Doritos tortilla chips is based on a regular hexagonal prism which has been shaped as shown. Figure B1 shows the incomplete diametric projection using the axonometric axis method of the package. The plan and elevation are shown in the required positions, okay? So part A here is draw the axonometric axes X, Y, and Z and the isosceles triangle ABC. Draw the plan and elevation oriented as shown. Part B. Part C is draw the axonometric projection of the portion of the package as given. Okay, part D. And then part D is complete the remainder of the package in the axonometric projection. So this question now is actually a lot of what we're drawing here. If part A, B, and C is just drawn what we are given. So that is actually, it's not too bad, okay? There's obviously going to be one or two little tricky bits that they're going to try and catch out here, but overall now that isn't too bad of a question to get to start off. So we're going to start there by drawing our X, Y, and Z axis, okay? So we'll start by drawing our Y axis here. We'll measure off 115 degrees each side, and then we'll set up our 120 line and we'll draw up our triangle ABC. Okay, so again, as in all other videos, we're going to use our red biro for constructions and our black biro then for heavy things. So just looking at the question here, this is set up to the right here, this is here, so we're looking at setup 120. It doesn't really project much past 120, so if I bring my center line here in about 70 or 80 from the edge of the left hand side of the sheet, I should fit the question on fairly good. So I got plenty of space there. I'm going to bring in 90 millimeters. Okay, I'm going to drop my Y axis. Okay, and it's diametric, so that means it's two of the angles are the same. Okay, so I'm going to pick a point there, and I'm going to set up my projector here, and I'm measuring 115. 115 this way. And then 115 in the opposite direction. Okay, so that's our axis Y, Z, and X set up there like that. And that is, then they want us to draw the triangle ABC. So I'm going to just come down here and draw a light line down here. So this question tells us exactly how to draw this line here. So the 120, the baseline there is 120, that's down the middle there. So we can draw in that from the center. We can actually just go 60 either side of this up here. Either side of our axis, that's drawn real light there because I don't want it to be going in. 60 there, 120. And I'm just going to drop those points down onto my axis there. Yeah, that gives me a horizontal line. So that gives me the x-axis. Now, how do I draw the remainder of my triangle? Well, edges up here. Well, my edge AC here is parallel to my z-axis here. Or sorry, perpendicular to my z-axis, okay? So if I'm going to set up my view here, I'm going to set up my set square there. I'm going to flip it over then so it's perpendicular to my z-axis. And it's the same then, obviously I can just join it up here, but it'd be the same over here. It'd be perpendicular to my x-axis here on this side. Okay, so that's key because we need to have those axes correct, because this edge here, this length AC determines the height of our elevation up here, and same down here BC. It doesn't give us a whole pile of measurements, but they're taken from this. Okay, so that's part A, B, and C. So I'm just going to label this A, B, and C there, and that's our first part of the question done. Part B of the question now asks us to draw the planned elevation orientated as shown. Okay, so we're drawing the planned elevation as shown. Okay, so I'm going to start with the plan here, because that's what it's actually telling me here. So I'm going to drop my line down. I have a line drawn here already. I'm just trying to gauge it down. I want to keep it as far away from as possible here, because I don't want to be getting it mixed up on the sheet. So I am going to bring that down. Just looking at it, it's roughly sphere 60. Yeah, do you know what? That line there that I have drawn already, I think is probably as good as it's going to get. So we draw our line across there. We drop down this edge here. That's our length. And we're dropping down our axis as well. Okay, so we've bisected that line. We bisect this line here. We stick our compass in either side, and we swing it around. Okay, got me good compass, but we swing it around. Okay, and then we join the edge of this line back here for our triangle here. So that sets up our angles there. That sets up the stair to that there. Okay, so we're taking measurements here, so we're going to take our measurements of this guy of the hexagon in the base, which is 20, 40, 20. Okay, and now we're drawing a hexagon. There's another hexagon inside there in the middle of it as well. So we're just going to have a look at this now. I'm just going to draw these lines down lightly here. Now, what are we looking for here? Well, when we use this hexagon inside here, do we need to use this hexagon? I'm just trying to think now, do we need to use this hexagon? The angle in here is obviously 60 degrees. That's the angle there is 60 degrees, because we have 6 sides, so 360 divided by 6. So the external angle is 60, so the angle out there is 60. So I can do that with numerals. I can take my protractor. And I can just measure up 60 up here. And I can join that out there to hit that edge. Also, I'm thinking this is a hexagon, so that's 40. So I should be able to take that 40 distance into a regular hexagon, I believe. Does it tell us? Yeah, a regular hexagonal prism. So I can just actually swing that around. Okay. Sometimes it actually there's no issues in the question whatsoever. Quite simple, but we just look past it. So we can actually just swing those around because it's a regular prism, regular hexagon. That's a regular hexagon there, and all edges are the same, and they're giving us one edge. So that's grand. So I'm going to heavy in that hexagon there now. So I'm just trying to figure out what's this broken hexagon in the middle for. It looks like it's the middle of the box. The inside hexagon is halfway down the middle of it. And we can actually, they're just all bisectors of that, so if that's 40, we can just take 20, just step off 20. They're all just bisectors of this hexagon. And then we just broken lines here then for this. Perfect, and that is the plan then there set up like that. Then we're going to pop up the elevation here, so we're going to start by extending out our z-axis. Extend our z-axis out there. Set up perpendicular to it. And we're going to continue out the line AC here, so that's A there. Slide this up here. Oh. Okay. So what do we need to do now? Now we need to bisect this line out here that we projected out here. So I'm going to bisect this line out here. See where it goes. So I extend my compass more than half the length of the line. Swing an arc. Swing an arc to where they cross. What do you mean? There. There we go. Center my line. I'm going to take the distance then, half the distance to that line. I'm going to swing around. And then our axis then is created by joining this back to our z-axis, because that's the base of it. So that's the setup there, that question there. That's probably the big key thing that we're missing out of this, the height of that. So we need that height there. We need that height there to give us this line there. Okay, and once we have the axis there, we've got the heights, so we can step off onto these heights here. We've also got the widths then, so we can step off onto these as well. So it's 20, 40, 20, and same vertically then. It's just, and here we're going to look. 20 adds up 20. So this part is actually where it's probably very handy to have a retractable or a adjustable set square now, because you can set up your adjustable set square to the angle that you need to bring these back at. Now I don't actually have it on me because inside in school we're locked up with everything else, but I'm gonna make do without it. So just up that height there. Oh, and this half line as well. Okay, and we're just going to heavy that in. So that's part B of the question. This is a nice question now. It's a nice enough question. So going back there. Over here. And we got the center right here. Lovely, and that's part B there done now. Okay, part C here is draw the axonometric projection of the portion of the package given as shown. So it's just actually asking us to draw this little section in here. So that's just the case now. Bring these points back down at the angles they're at, same as the same angle as the X or the Z axis, and bringing up the same points from plan, and we get these points here. Okay, so that's nice and easy. That's not too bad. So as I said, this is where the protractable set square would be real handy now. You just set up the angle there, so you keep your T-square horizontal. You set up the angle, you can bring them all back in. Obviously you don't have it, but sure. What can we do? So I'm just going to take this point, bring it back. Take this point, bring it back. Okay, and at this point now, it might even be handy just to label all these here. So labeling makes our life a hell of a lot easier. So I'm going to call this A, B, C, D, E, and F. And just make sure now when we do label it that we're just very careful about making sure that we line up here. So I'm currently looking in here. I'm standing here looking in there, and that's giving me this view up here. So my edge view over here is A. I've got F and B, B being at the back. I've got E and C, and I've got D at the edge here. So that now just means when I come over here to label this up, it's really easy for me to see here that have I done that right now? Yep, F is here. So I'm looking here, so this is my F here, so this is my F up there, yeah. So I brought F and FBEC across, so I'm just going to bring up the front of it, that's what I want. So I'm going to bring up F here, and I'm going to bring up E. And I'm just going to match them up there. So that's F and E there. Same for the plan. Line up that my protractor set square with my Z axis, and bring F and E back down here. E there. I can bring it back as well on the other side. F there is brought back. Okay. I'll let you notice these are horizontal lines. These go back the same angle as my Z axis on the other side. Okay. They are brought up a height, so the heights isn't the same. We don't need to be. We don't measure at all. We just set up our angle. That's FB there. Brought back, that's my height there. Same on this side. So my angle there. My height there, bring it back. And they are going parallel to the x-axis. Okay, and then I can just join up the rest of them together then. And that's that view there. Okay, so that's just draw C, is draw the axonometric projection of the portion of the package is given. Complete the remainder package. So part D then is complete the remainder of the package in the axonometric projection. So we're just doing the exact same then for the rest of it. Okay, so I brought D there, so I'm gonna bring it down here now. So up this line here. Bring down D. I'm going to bring D vertically up. Okay. So there's D there. Let's go and go back to that guy. And if I take the height of it here, it's just as easy now to take the height of it. There's D there. And I can see C here as well, so I'm gonna bring C vertically up. And C is actually on the same line as my E there. So that's my point C there. And that's it above it there. That's the base of it. So I'm looking in here. What am I seeing when I look in here? Well, this is the shape I'm seeing up here. This is the shape. So if I start by just creating, as I said, I'm going to do the same up the top then. If I just bring up these guys straight up, it'll and again, I just bring back D on the bottom here. Sorry, I went E first. E is over here. And sorry, that's not right. Sorry, the D is what I'm looking for. D is down the bottom here. So this guy here, this guy here, and then E is here, and E is here. Yeah, so I was wondering why those my heights were looking a bit off. So again, just make sure that we have our set square at the correct angle. Okay, so this is the bottom E here. It's the top E there. It's the top D. The top C there. And just heavy it in there. Okay. Right, and you can actually finish off the top of the thing, the hexagon in here, because we're able to see the top of this. So that's A there. So we're going to bring up A. Bring up B. B at the back. So that's A there. And then B at the back here. So that's the top of A there. There's B there. And that's back over into C. Okay, so that's the top of the hexagon finished off, and then we've got the bottom of it finished off there then. Okay, now we're just trying to figure out here then. So then this corner obviously is going back up to there. This edge is going back up to there. This edge here is joining back up to this guy. And on this side. Up to there. And this guy is going up into there. So we bring those lines down there. Yeah, that's where they cross there. Perfect. Come across there. This is going to come across here. Now we've got a small little bit on the other side here. So this edge here is actually seen on the other side. So if we just bring this final edge down here. So say we're the line A. So this guy here, what we're looking at, see, we can see this point here. This point here, I'm going to call this point X. That point X there is here. And if you're looking in from here, you can actually see point X joining back into this guy here. So what we need to do is we need to bring point X down. Okay, so bring point X down. Bring point X up. And that's point X there. And we know that point X joins to A, which is back there. I know, I just have my mark point X, which it's in the middle here, it's coming back in the middle. We know it joins to A and it joins to F. A and F. So we can see F in the front here. So it's coming back down here. And we know that it's also going up to the back up there, up to our point A. And that is the question then solved. We'll just have a look here. Can we just see everything? We've looked in here, we've found all these points. Okay, they're all there. We can't see anything, that's all the rest of the back and the front. We'll just have a look at the question here. Complete the remainder of the package in axometric projection. Yep. That's the final solution. So that's a nice question. Takes a little bit of time, but it's relatively straightforward, and they basically explain to you what you have to do for each part. Cool.